In today's video, we're going to be talking about graphing. After watching this video, you should know how to properly create a graph and familiarize yourself with some of the types of graphs that we will be seeing in class this year. So let's get right into it. The first thing I want to talk about is independent and dependent variables. And this always is a tough concept for people to wrap their minds around, but the independent variable is the factor that the scientist changes or manipulates in an experiment. So it's a thing that you are going to be testing, if you will, that you want to find out information about, and the thing that you're going to be changing or manipulating. And it goes on the x-axis. The independent variable always goes on the x-axis. Typically, time is an independent variable, and it's almost always going to be found on the x-axis. Not always, but typically, if you've done any experiment with time, that's going to be going on the x-axis. The dependent variable is the factor that is affected or changed by the independent variable. Okay, so that's going to go on the y-axis. So this, it's kind of like it's the results of the experiment, the thing that you're seeing what happened. So because I did this, what's going to happen? Okay, it's dependent upon that independent variable. Okay, and that always goes on the y-axis. Just some general graphing tips and ways to maximize the amount of points you get on lab write-ups is make sure your graph has a title. Okay, it's nice to know what I'm looking at if I'm looking at a graph. If it has no title, I have no idea what that graph is talking about. So having a title is always useful. Make sure the x and y axis is labeled and has the appropriate units. Once again, if I'm looking at a graph and I have no idea what the x-axis is or what the y-axis is, I have no idea what's being compared or what I'm looking at. So labeling stuff is always important, and it's always also important to include units. Okay, I mean, did you measure this in feet, meters? You know, how did you do this? Okay. And then the last thing is sometimes I'll see people make these graphs and they're so small they take up just like the little corner of the graph paper. Make sure your graph takes up as much of the page as possible. And sometimes we'll be using Microsoft Excel to create our graphs, but other times it's just going to be the old graph paper and pencil method. And so when you're the one doing it, make sure you try to have it take up as much of the page as possible. It really is a matter of spacing your units, scaling your units on your x and y axis correctly. Okay, so let's talk about some of the types of graphing relationships that you will see in this class. Let me change my pen color so you actually can see it, which is always helpful, at least I think. We'll do red. So the first type is called a linear relationship, and it basically follows this formula that I'm sure you guys have seen before, y equals mx plus b. Okay. And a linear relationship is relatively simple. Let me just kind of sketch out a graph here. Let's say I'm comparing let's say the mass on a spring. Okay, I want to know if I and I'm not a good artist, but let's say I have a spring here and I put different masses on this spring. How much does the spring stretch? Okay, how much does this stretch based upon the masses? And you probably can guess as I add more mass to the spring, it's going to stretch more. Okay. The thing that I am controlling, the thing that I'm in charge of, is I'm going to be changing these masses, right? Maybe I put a 50-gram mass on there, maybe I put a 100-gram mass on there. That's what I'm in charge of. And so that is the independent variable, and that is going to go on my x-axis. And I'm going to measure mass in grams. We'll actually do kilograms because grams is kind of small to stretch a spring. So we'll say it's in kilograms. And then what is the dependent variable? What am I looking at to see happen to the spring? What is the result? Well, I'm wondering what the length is. And I am not real good at writing. Oh, actually, it turned out kind of nice. Length, and we'll measure that in meters. Okay, how many meters does it stretch? Which probably is unreal, or is not realistic, because that would be one big spring if it's stretching multiple meters. It'd probably be more like centimeters I'd be measuring in. But whatever, we'll just stick with that. The point is, a linear relationship, if you get your points, it's going to be looking something like this. Okay, it's basically just kind of a straight line. Now this line that I created is a line that's called best fit. basically, I try to have it fit within all the data points as best as possible. You'll notice it doesn't run through each of them. It's not like it, you know, goes from here to here to there. It just goes straight through them as best fit as possible. Okay, and that's how you should draw a linear relationship. The next type is a nonlinear relationship. It's actually a quadratic relationship between two variables. And the formula is y equals ax squared plus bx plus c. And for this example, let's say I'm in a building. I'm on the, we'll say the 70th floor. And I'm going to drop a penny down to the earth, which is down here. Okay. And I'm going to time how long it takes to travel this distance, okay, this distance here, okay? So I'm going to, again, set up a graph. The independent variable is almost always going to be time. Anytime there's time involved, it's going to probably go on your x-axis. So the time is the thing I'm controlling. How long will I allow this thing to fall before I measure a distance? The time is going to be measured in seconds. And we'll say the distance, which will go on my y-axis because my dependent variable, would be measured in meters. Now, how is this different than a linear relationship? Typically, these graphs look something like this, that they are kind of curved. Okay, and this kind of makes sense. As the penny has more time, it's going to travel a further and further distance for every second that passes by. Let's say you jump out of a plane. Well, you start falling down to the ground sort of slowly, relatively speaking, but you know, maybe 10 seconds after the jump, your body's falling pretty fast towards the ground. Well, the same is true of a penny. As time passes, the penny is going to cover a larger and larger distance. Okay, and so this is what's called a quadratic relationship. It kind of looks something like this. And again, these should have titles, and I'm sorry I'm not exactly following my rules to a T here, but there should be a title on this. The last type of relationship I like to talk to is something called an inverse relationship. And the kind of generic formula for that is y equals a over x. Okay, and basically what it's kind of saying is as x increases, y decreases, or as x decreases, y increases. So they do the opposite of one another. That's hence the name inverse. Okay, so let's say I'm in an electricity unit, and I'm going to measure the current in a wire. Okay, and this gets kind of ahead of ourselves here, but the symbol for a resistor is this kind of squiggly line, and basically a resistor just slows down current. Okay, so let's say I measure the current in this wire with only one resistor, and I get a number. And then I add another resistor, and I measure the current. And then I add another resistor, and I measure the current. And I do another one, and I keep going, so forth. Okay, what happens to the current as I add resistance? Okay, that's the question. So I'm going to again draw my graph. The thing that I'm in charge of is I'm in charge of adding these resistors, right? I can put as many or as few resistors as I want in this circuit. And so I'm going to write resistance down here. And you don't need to know this, but the unit of resistance is something called the ohm. And that's the Greek letter omega. So there it is, resistance. And the current, you may remember this from before, is measured in amps, okay, and it's usually represented with the symbol A. Okay, so it's not super important that you understand that at this exact moment, but we did talk a little bit about it in one of the previous lessons. So an inverse relationship kind of looks something like this, where it's going to decrease downwards, and I'm not the best artist, but it's not headed up as you move horizontally along the x-axis. Instead, it decreases or goes downward. Okay, so basically what this is saying is as I add resistance, the current is going to decrease, which kind of makes sense, because if a resistor's role is to decrease the current, if you add more of them, the current is going to decrease. All right, that takes care of this video. I will see you guys next time.